Okay, next is example 3. So we have 3 loops of wire shown in figure above, all in a region of space with uniform magnetic field. Loop 1 swing back and forth like this, and then the second loop is rotating. Okay, loop 2 is rotate about vertical axis, and loop 3 is oscillate vertically, means that up and down. Okay, which loop have a magnetic flux that change with time? Explain your answer. Okay, so kalau kita buat secara manually, kita tahu kalau you kata you gerak back and forth macam ni, okay, like this, so dia takkan ada perubahan apa-apa. Area tak berubah, B tak berubah, and then dia punya angle pun tak berubah. Even you duduk sebelah sini, angle tetap sama, and bila duduk sebelah sini pun angle-nya tetap sama bila loop duduk. So from the side view, daripada pandangan tepi kita akan nampak initially untuk loop 1 sama je after few second pun, forth and forth and back. Okay, sama, no change. Okay, for loop 2 dia kata rotate. Bila rotate, initially you nampak macam ni, kedudukan dia like this, means that the plane and the B, means that the plane is parallel to B. Jadi vektor area A dengan B, angle dia kosong. Tapi bila kita rotate, so plane ni akan jadi parallel dengan B pula. So vektor area A dengan B akan jadi 90 degree. So kat sini kita dah nampak dah, bila dia rotate means that dia akan change angle. Okay, loop 3, atas dan bawah. Atas dan bawah maksudnya dia no change, sama macam case yang depan dan belakang. So dekat sini, bila no change of angle, no change of area, no change of B, so the loop does not experience any change of flux duration time, tak ada. Jadi only loop 2 have the magnetic flux that can change with time because the angle keep changing according to the equation of magnetic flux, BA cos theta. Okay, theta is directly proportional dengan flux. Kalau theta means that cos theta tu berubah, means that the magnetic flux pun berubah. Okay, the answer is loop 2. Okay, as 5.2 induced EMF, example 4. Okay, the magnetic flux passing through the single turn of coil increase quickly but steadily at rate of 5 times 10 to the power of negative 2 Weber per second. If the coil have 500 turns, calculate the magnitude of the induced EMF in the coil. Dia nak magnitude je kan? So, induced EMF is equal to negative and the flux per dt. Tapi disebabkan dia just nak magnitude, so abaikan je lah negatif tu. Okay, boleh je lah abaikan. So 500, okay, so times with the flux per dt. Yang ni 5 times 10 to the power of negative 2 tu adalah Weber per second. Maksudnya dah di flux per dt lah. So we get the answer is 25 volt. Okay, so next question is example 5. Okay, example 5. We have 20 cm long metal rod CD is moved at speed of 25 meter per second across the uniform magnetic field of flux density 250 millitesla. The motion of rod is perpendicular to the magnetic field and shown in figure. So number A, calculate the motion induced EMF in the rod. Maksudnya dia nak motional induced EMF in the rod. So dia nak induced EMF. Induced EMF is equal to BLV sin theta. Sebab dia adalah conductor rod moving kan. So B is 250 times 10 to the power of negative 3. L is 20 cm 10 to the power of negative 2. And then V is 25 millisecond sin 90. Okay, so we get the value of induced EMF is 1.25 volt. Okay, so next B, if the rod is connected in series to the resistor of resistance 15 ohm, determine the induced current and its direction. Connected in series with wire, maksudnya you just lukis je wire tu kat mana pun tak apa. In series kan, macam tu je lah. Tapi selalunya dekat ni ada resistor lah. Contoh dia letak satu resistor. Contoh. Okay. Alright. So the road is connected and then determine the induced current and its direction. Okay. So induced current and its direction. Senang je. Induced current macam saya kata, I induced is based on Ohm's law tu. Sama dengan E induced divided by R. Okay, so induced is 1.25 divided by 15. So we get the answer is 8.33 times 10 to the power of negative 2 ampere. Okay, direction dia kat mana? You boleh guna Fleming left hand rule, di mana direction of V always oppose direction of F lah. Okay, guna tangan kiri. F is to the right, and then kita punya B is out of pitch. B is out of pitch, and then current is from D to C. Nampak tak current dia ke atas? Okay, current adalah D to C. Guna huruf lah, senang. D to C. Dia ada huruf kat sini kan? Okay, so betul FB tangan kiri, FB ke kanan, B dia out of pitch, and then I dia ke atas. So D to C. To C. Okay. Alright, so next, the total charge passing through the resistor in 2 minutes. Total charge. Masih ingat lagi tak formula yang melibatkan charge? Q is equal to IT. So I ni induce lah 8.33 times 10 to the power of negative 2. In 2 minutes, 2 is times with 60 second. Okay. So 10 coulomb.